Well, not so straightforward, but still very interesting, would be finding the parametric equations for surfaces of revolution. You may recall from Calculus 2, finding the volume of a solid of revolution, or finding the surface area of a surface of revolution. Now we're just going to find the equation of the surface as a set of parametric equations, or, like I say, by extension, vector valued function. So this is not that straightforward, but we can do it. So if you reason, we are making cross-sectional circles along the axis of rotation. In other words, if we're rotating about the x-axis, then we're just making a bunch of circles. Recall the method of disks or washers, how that makes circles. And each has radius f of x if we're rotating about the x-axis, f of y if we're rotating about the y-axis, or f of z if we're rotating about the z-axis. It's easily understood what the formula would be. To obtain a parametric equations for the surface made by y equals f of x rotated about the x-axis, we use the following. X of uv equals u. Duh. Y of uv equals, now here's where you gotta pay attention, f of u, that's this f, right, times cosine of v. And z of uv is f of uv times sine of v, and this will give you the parametric surface that is the graph of y equals f of x rotated about the x-axis. So part of the homework is you got to figure out what it is if we take x equals g of y and rotate it about the y-axis, but I'll let that be your special assignment. And if you wanted to, you could even say, what would it be if I rotated maybe something like y equals f of g, or x equals, sorry, I didn't say it right, y equals f of z, or x equals f of z, and rotate that about the z-axis. That might be interesting also. Okay, here's an example. Find the parametric equations for the surface formed when f of x equals 1 over x on the interval from 1 to 10 is revolved about the x-axis, and sketch the graph. No one would ask you to do that by hand, I think, but yeah, this one's one you actually probably could, with just a little bit of drawing skill, do by hand. Skilled drawer would have no trouble with it, but that leaves me out. So, all right, well, I already described it. X of uv is u, so f of uv is u. I'm making this the x component. The y component is g of uv equals 1 over u, that's our f of x, times the cosine of v, and h of uv equals 1 over u sine of v, u going from 1 to 10. See, remember x going from 1 to 10? So u going from 1 to 10, and v going from 0 to 2 pi. And I want you to think about why 0 would be going from 0 to 2 pi. Like, what would be different if it went just to pi? It might only be half of the rotation. Then we want the entire rotation. We want the entire circle for each cross section. So what does this thing look like? Well, you might have seen this example. It's a really great example from Calculus 2, that if you continue this forever, after you've learned about improper integrals, continue that out to infinity instead of the interval 1 to infinity, this particular graph has infinite surface area yet finite volume. I think you might look up Gabriel's horn for one of those weird paradoxes. Of course, this one doesn't go on forever, because you can see it's got a hole there at 10, because I stopped it at 10. But that is how we find, and an example of, the parametric surface that represents a solid of revolution.